Hi, so this is the last class of the continuation of your elementary statistics, in which we will be first going through goodness of feet, then some common regression things, and then GPU computation. Okay, so why do we need goodness of feet? As you can know that many distributions in real life basically follows theoretical distribution, right? Distributions. So to check whether it's following some theoretical distributions, that you have some data files and you have some assumptions that this might be following some chi-square distribution or normal distribution or something like that. So you have to confirm that. So for that you need how good your data is to fit in the distribution that you have the assumptions. Okay. So first thing is that we will be seeing is multinomial goodness of fit. So the code is not important, but the concept multinomial goodness of fit. You have to understand the concepts because the code can be copied from any place. So what is multinomial? Okay, so basically any population data is called multinomial if its data is categorical, and basically it belongs to a collection of discrete non-overlapping classes, right? So what are the two things that derives the multinomial dimension? First, it has to be categorical, and second, it has to be, first thing is categorical, and second, it has to be discrete classes, basically non-overlapping. Okay, so some people in messages asked me what you do. So in this meantime, I thought I should let them know that okay, so I am doing currently a masters from IIT Roorkee. In previous, I have done my BTech from Jadavpur University, and I worked in two companies as a data science consultant. And after that, I served approximately 12 to 13 projects as a freelancer in data science and machine learning. And in IIT Roorkee, I am doing one startup with my professors. Okay, so that's about me. Now let's move to multinomial goodness of fit. So multinomial means it has to be categorical, and the discrete classes has to be non-overlapping. Okay, so in this case, the null hypothesis, you always remember, whatever you do, you have to build one null hypothesis always when you are assuming something, because that's the thing, that is the statement that you're going to execute in later on. So for multinomial distribution, the null hypothesis is that observed frequencies is equal to an expected count E in each category is to be rejected if p-values of some chi-square statistics is less than a given significance interval. Okay, so we'll be get into it with probably you don't understand by only saying this. So let's do this. Let's solve this multinomial goodness of fit with one example. So now in case of a example, okay, we have previously used a survey dataset from mass library, right? Took mass, just execute it. done. Now it has a data set that we are going to use here, that is survey. So see some of the values that it has: sex, with some fold, pulse, clap, smoke, height, age, mi, all that. These are the variables or things. So now the matter of interest here is smoke. Okay, so either I mean how frequent the person, like probably it's some patient database. So you can do the str survey and smoke and see the structure. It says that it has a factor of 4 levels. Let's now examine the levels. The scores are not important, but the concept is very much important. So if you are not following the code, it's okay, but you have to follow the concepts. So as you can see, it has a level heavy, never, occasional and regular. Okay, now we have done the frequency distribution for qualitative data. This is the qualitative data, right? So if you have to build a table for the frequency, which is our matter of interest, then it will be table survey, and you have to find the smoke, and you will have the table, and then just you print the table. As you can see, you have a table where it's like tabulated, never is most highest 189. So now in a problem that suppose you are in your college campus or your office premise, and you have the data, okay, which says that heavy has a probability percentage of 4.5%, never has a 80, around 80%, or occasionally there are some different percentages you have get from a survey. Okay, these are your basically, suppose your home statistics or your office statistics or your campus statistics. Now your like intuition is to determine whether the sample data in the survey, so this is your sample data in the survey data set, supports it at 0.05% significance interval. Okay, whether this data is supports your actual data. Okay, so if that happens, what you can do, you can apply the same concepts and principle to your survey data, and you can make conclusion about your original data, right? So let's build quickly one smoke probability object where you will have your 0 point, let's take it 0.45, then let's take 0.795. These are in order, right? So heavy is basically 4.5%, never is 79.5%. This is your data. 0.85, 0.075. okay, this is the probability. Now what you have to do in this case, where you are intuitively asking repeatedly to check whether this frequency, like smoke frequency, uh, and the smoke probability has any kind of similarity. These both are categorical and these both are discrete classes, you have to always remember. Now you will be using here Chisquared test. Okay, So Chi-squared test is basically where it's used in multinomial good categorical data, where you have some discrete classes. So this is the command for Chi-squared test. Basically we will type chi and that thing will pop up. We will pass the smoke frequency, which is your data, and in probability we will pass smoke probability, and we will just run this. Probably I haven't run this, that's why I'm getting the error, and now you are running this and you will get that chi-squared test for given probability. X squared value is 0.1, degree of freedom is 3, obviously it's number of variables -1, and p value is 1. So as your p value is greater than your significance level, we do not reject the null hypothesis, right? That the sample data in the survey supports the campus-wide smoking statistics. So this is a simple thing that you have to remember, that now from how to write this result, that your p-value is greater than your significance interval, so you are not going to reject null hypothesis. Okay. See, in internet only learning how to learn data science, how to become a data scientist, these kinds of video won't give you a job in data science. Okay, so you have to learn data science, and you have to learn it in a manner like you used to learn history or geography. This is also another field, but it's a very vast topics covered in data scientist or data science or machine learning. So if you are just starting, or if you are in halfway, so you probably will need to be focused on what you have learned so far. You have to practice the concepts. Code is not important again. You have to practice the concepts, because that's what makes you a good data scientist in the field, and makes your skills demanding. Okay, only certification won't give you a job. So this is what we have done, multinomial goodness of fit. Next we will be doing chi-squared test of independence. Okay, so we are now in chi-squared test of independence. So suppose two random variables you have, x and y, and you know that they are independent. Okay, so how you can know that they are independent? Basically, if one's probability distribution doesn't affects the others, right? So now we'll again do the same thing with survey and exercise. So let's now took one intuition, that your exercise level, if you see the data set here, it has a column for exercise, that some, none, and all that. Okay, so your exercise level and your smoking habit, these both are independent. Like most probably doctors used to conclude that your smoking habit is related to exercise, but let's make a call here that our smoking habit is not a way related to our exercise level. Okay, so same thing, make one table table survey, and you need smoke, and survey you need exercise, right? And you just run this command, so you have a tabular format of these two things, like whether it's if you are a heavy smoker, how often like you do exercise. If you never smokes, how often do you exercise. If you are a regular smoker, how often do you exercise, right? So the next thing is what we have to check this with Chi-squared test of independence, right? So the thing is same. This is the Chi-squared test, and you have to pass the table. Okay, so as you can see that this is Pearson Chi-square test. You have a degree of freedom of 6, you have a p-value of 0.5. To be very honest, this is not actually 0.5, this is basically around 0.48. So anyways, and you have one indication also that chi-square approximation may be incorrect. Okay, so we'll be ignoring the warning message, and from based on this p-value we will conclude as your p-value is more than 5%, it's approximately 50%, so you cannot reject the null hypothesis. Null hypothesis, which is basically here that there is no correlation or there is no dependency between your smoking habit and your exercise. So if you do a lot of exercise, you still may be a heavy smoker. If you don't like smoke at all, it doesn't certainly implies that you do a jogging, which fairly makes sense. So you can do that test with Chi-squared test. So this kind of test will be requiring when you are doing any project, and you have to make conclusions based upon collinearity. All the time you cannot only rely upon heat plots or heat maps. You also have to do Chi-squared test, which is very helpful to give you intuition. So that's it for today. Thank you.